Hello everyone, myself Koushik. I am a senior lecturer in GIT Polytechnic from electrical department. Uh, Now I am going to take a smart class on static VI characteristics of SCR or a thyristor. Here I have written static VI characteristics of SCR or thyristor. Now, first of all, we have to discuss about what is the difference between the SCR and a thyristor. Thyristor is a family name, and SCR is the family member of the thyristor family. Okay. So now let us discuss about the VI characteristics of SCR. So what is, first of all, let us study about the SCR. What is a SCR? It stands for S for silicon, C for controlled, and R for rectifier. That means this component or this equipment is made up of silicon material, silicon semiconducting material, and it is a rectifier. That means it converts AC to DC voltage, and it is a controlled rectifier. That means we can control how much signal we have to convert from AC to DC. So that's why this is called as a silicon controlled rectifier or SCR. Now let us discuss about the construction of the SCR. How it is made up of. Silicon controlled rectifier or SCR is a 4-layer, 3-junction, 3-terminal semiconducting material. Okay. So now let us discuss. It is a 4-layer. That means it has 4 layers. 1, 2, 3, and 4. And it is naming as P, N, P, N, and it has 3 junctions, that is J1, J2, J3. Junctions means whenever a P and N is connected, the middle terminal is known as your junction. J1, J2, J3, that is 3 junctions in a SCR, and there are 3 terminals also, that is anode, cathode, and this is your gate terminal. We know anode is a positive terminal. By default, we generally consider as your anode is a positive terminal, cathode is your negative terminal, and extra terminal is connected to this 3rd layer, that is to the P-type material, that is your gate terminal. Okay. Now let us discuss about the working of the SCR or the VI characteristics of the SCR. So to draw the VI characteristics of SCR, we have to put a graph by taking your x-axis as your voltage and y-axis as your current. That is your, I have written your VA and IA. That is, VA means your anode voltage and IA means your anode current. Now we will discuss about how the voltage and current characteristics graph will come when the SCR will in working condition. SCR operates in 3 modes. The 3 modes are forward, locking mode, Second, forward conduction mode. Third, reverse blocking mode. In these three modes, the SCR operates. The first one is your forward blocking modes. Forward blocking modes, that means in this mode, the SCR is in forward bias position. That is, if I am drawing a SCR, the SCR will be in forward bias condition. That means the anode is given as the anode is in higher potential with respect to the cathode. That is, anode is in positive, the cathode is in negative. So that's why the junction J1 will come in which type of biasing? That is in forward biasing. How? Because we know whenever a PN junction is connected to a battery source or a DC source, when the P-type material is connected to the positive terminal of the battery and the N-type terminal will be connected to the negative terminal of the battery, at that time we can say the PN junction will be in forward bias condition. So that's why this P-type material is connected to the anode, that is the positive terminal, and this N-type material is connected to the cathode, that is the negative terminal. So this P and N, the junction J1 will be in the forward bias condition, and the junction J3, the N-type is connected to the negative terminal. So that's why the P will be in the positive terminal. So that's why the J3 junction will be in the forward bias. But the junction J2 is in the reverse bias condition. How it is? Now look, this N-type terminal is connected to the positive terminal and this P-type material is connected to the negative terminal. So we know that whenever a PN junction is connected to the battery source, when the P-type material is connected to the negative terminal of the battery source and the N-type terminal is connected to the positive terminal of the battery source, at that time we can say that will be in the reverse bias condition. So that's why the junction J2 will be in the reverse bias condition. So in this in this forward blocking mode, this is also an off state of the SCR, because the current cannot flow from anode to cathode, because this junction J2, that is in the reverse bias condition, it opposes the current that will be flowing from the anode to cathode, because this junction J1 is in forward bias, so that's why the current can flow. The junction J3 is in forward bias, that's why the current can flow. But the junction J2 is in reverse bias condition, so that's why the current cannot flow in the junction J2. So that's why we can say the SCR is in off condition. But here some leakage current will be flowing through this junction J1 and J3. So that's why we have to show that leakage current in the graph like this. This is your leakage current. It will be in the low magnitude or small magnitude, because only small amount means that some few milliampere will flowing through this junction J1 and J3. So that is your leakage current. This is your forward blocking mode, that is I am writing here FBM, forward blocking mode. Next, the second mode is your forward conduction mode. This is your forward blocking mode. Next is your forward conduction mode. Now look, in the forward conduction mode, it is the on state of the SCR. How I am converting the junction J2 from reverse bias condition to the forward bias condition. At that time I can say the whole three junction will be in the forward bias condition and the SCR is in on condition and the current can flow from the anode to cathode. Now how we can convert the junction J2 from reverse bias to forward bias? There are different types of method by which we can converting the reverse bias to the forward bias, but in this VI characteristics, we generally what we are doing, we generally increase the supply voltage at the anode to cathode voltage, by which after some time there will be avalanche breakdown in the PN junction. That's why the reverse bias will be converted from reverse bias to forward bias. We know whenever a PN junction is connected, in reverse bias condition, so that will be a barrier created. This is your depletion layer. In the reverse bias condition, the current cannot easily flow due to this depletion layer because there will be high impedance. So what we are doing, whenever we increase this supply voltage, at the time after some time at this junction there will be a avalanche breakdown. Due to this avalanche breakdown, the reverse bias will be converted to the forward bias and the current can easily flow. So in this static VI characteristics of the SCR, also we are increasing the supply voltage. That's why after some time that will be a breakdown in the junction J2, that will be the avalanche breakdown. So that's why this J2 junction will be converted from reverse bias to the forward bias condition. So whenever the junction breaks, at that point we can say that point is your VBO. What is this VBO? This VBO is your forward breakover voltage. Forward breakover voltage. At this voltage, the junction J2 will be converted from reverse bias to forward bias, and after converting from reverse bias to forward bias, all three junctions will be in the forward bias condition. That's why we can say this is converted into forward bias because we have increased the supply voltage. So all three junctions are in the forward bias condition. The current can flow from anode to cathode, and here we can say at this VBO point the current will easily flow linearly this is your forward conduction mode. Then the last one, this completes our forward conduction mode, and this is the only mode when the SCR will be in on condition. Next, the last one, the last mode is your reverse blocking mode. As the name suggests, it is a reverse blocking mode. So that's why you can say the SCR is in reverse bias condition. So what is this reverse bias condition? That means in the forward blocking mode we are taking the anode is in higher potential with respect to cathode, but in reverse blocking mode we have to take the cathode will be in higher potential with respect to anode. So that's why this will be changed. That means the cathode will be, I am taking this cathode as positive, this anode as negative. So when the anode is negative and cathode is positive, the junction will be also changed. So what will be the junction remains? So the junction J1 will be in Which biasing? Now look, this P type material is connected to the negative terminal of the battery, and this N will be connected to the positive also. So the J1 is in reverse bias condition. Next, the positive terminal is connected to the N type material of the SCR, and the P will be in negative terminal. So J3 junction also will be in the reverse bias, because we all know in the previous class the PN junctions, forward bias, reverse bias. So what is biasing? Biasing means whenever we'll give the external DC supply to a transistor, that will be known as your biasing. So the junction J2 will be in the forward bias condition, because the P is connected to the positive, N is connected to the negative. So that's why this is in the forward bias condition. So in this reverse blocking mode, what is happening? Now due to this forward bias condition of the J2 junction, only in the J2 junction the current flows, small amount of current flows, that is the leakage current, flows through the junction J2. That leakage current we have to produce in the graph. That will be like this. This is your reverse blocking mode. I am writing your RBN. Sorry. Reverse blocking mode. In this mode, what we are doing, the junction J2 is in forward bias, so that leakage current I have written here, I have done here in the graph, and after some time we gradually increasing the supply voltage, anode to cathode voltage. After some time there will be a breakdown. That is that point is your VBR. What is VBR? VBR stands for reverse breakdown voltage. At this voltage, the reverse bias J1 junction and the reverse bias J3 junction is converted to the forward bias condition, that is after some time, whenever we are gradually increasing the supply voltage, anode to cathode voltage, after some time there will be average breakdown in the junction J1 and J3, and the J1 will be converted from reverse bias to forward bias. J3 also converted from reverse bias to forward bias, and current can flow linearly. So that graph will be like this. This is your reverse blocking mode. This completes our static VI characteristics of SCR. Thank you very much.